Hello, 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 my fellow stargazers and cosmic enthusiasts. Leonard here, your guide to the grandeur of the cosmos, and welcome back to Universe 101. Today we're going to embark on a journey that will take us billions of years into the future, to the final stages of a star's life. We're going to explore the fate of white dwarfs, those stellar remnants that have exhausted their nuclear fuel and are now cooling off in the vast expanse of space. So buckle up and let's dive right in. Imagine, if you will, a pot of water on a stove. When you turn the heat on, the water begins to boil, creating steam. This is similar to a star in its main sequence, burning hydrogen to create helium and releasing energy in the process. But what happens when you turn the heat off? The water stops boiling and begins to cool, much like a star that has exhausted its nuclear fuel. This star, now a white dwarf, is no longer generating heat and begins to cool and fade away. White dwarfs are fascinating celestial objects. They're about the size of Earth, but with a mass comparable to that of our Sun. Imagine squeezing an elephant into a shoebox, and you'll get a sense of the incredible density we're talking about. But what happens to these dense, hot objects as they cool over billions of years? As a white dwarf cools, it begins to crystallize, starting from the core and moving outward. This process is akin to how water turns into ice in your freezer. The atoms in the white dwarf, once free to move around, now find themselves locked in a crystal lattice. This crystallization releases latent heat, which slows down the cooling process. It's like putting a hot pie in your window to cool. The pie doesn't instantly become cold, it takes time for the heat to escape. Over billions of years, the white dwarf continues to cool and crystallize until it becomes a solid sphere of crystal, a diamond in the sky. But the story doesn't end there. As the white dwarf cools, it also fades, its once brilliant light dimming until it becomes a black dwarf, a cold, dark, crystalline sphere floating in the vastness of space. But wait, there's a twist. The universe isn't old enough for any white dwarf to have completely cooled into a black dwarf. The oldest white dwarfs we've observed are still radiating heat, still in the process of cooling and crystallizing. So the existence of black dwarfs remains a theoretical prediction, a glimpse into the far, far future of our universe. Before we wrap up, I want to remind you to hit that like button if you've enjoyed our journey into the future of white dwarfs. And don't forget to subscribe to Universe 101 for more deep dives into the mysteries of our cosmos. Your support helps keep this channel going, and I appreciate every single one of you. In conclusion, the fate of white dwarfs is a testament to the incredible life cycle of stars and the vast timescales on which the universe operates. From their fiery birth in the crucible of a stellar nebula to their slow crystalline death as a black dwarf, stars are truly the cosmic clocks by which we measure the age of the universe. So the next time you look up at the night sky, remember, each twinkling light is a star on its own incredible journey through time and space. Until next time, keep looking up and keep wondering. This is Leonard signing off.